Hey again, everybody. I thought I would run through a couple examples using the second part of the fundamental theorem, so you can you'll be able to work through some of those examples from the book. The second part is essentially you've got an integral from, a lower limit to an upper limit of some function, which is going to be the antiderivative of that function evaluated at the upper limit minus that same antiderivative evaluated at the lower limit. So depending on the type of question and the way it's asked, you don't really know for sure what part of the fundamental theorem you're going to use till you actually, analyze the situation. If you've got a problem like in the previous video where you've got you're trying to take the derivative of some integral, well, then you're going to use the first part of the fundamental theorem. If you're actually trying to find a value, you're actually trying to, you've just got an integral here that you're trying to evaluate. That's basically saying find the area, right? Find the net area under a curve between whatever's above the x-axis and whatever's below the x-axis, and find that value. So, we've done this one, 1,000 times already, but I'm just going to do it again for the purposes of setting us up. And this is basically asking us what is the area under x squared from 0 to 5. And that's going to be x cubed over 3, evaluated between 0 and 5, which is 5 cubed over 3 minus 0 cubed over 3. And we've already seen this number many times because we've done this problem a few times already. But obviously, we're not limited to something like that. Suppose we had something like, negative 1 to 4 of 3x squared minus 2. Okay? Well, that's going to be 3x cubed over 3 minus 2x, there's my antiderivative, evaluated from negative 1 to 4. As long as the function's continuous over that interval, we can use the fundamental theorem. So there's no issues with negative 1 to 4, so we can just keep going. This is going to be, obviously the 3's cancel, so this is going to be 4 cubed minus 8 minus negative 1 plus 2 when I plug in that negative 1. So 64 minus 8 plus 1 minus 2 is what, 55? That sound right? Okay, so that's really all you're doing. But what's really neat is actually we could do this on our calculator. I know we didn't have time in class for me to show you that, but let's go ahead and take a look at our calculator and see if we can't do something very similar. Alright, so I have my calculator out now, and I'm going to basically do this exact same problem that we just did, but on our calculator, just to kind of show it. So I'm going to switch over here. Let's go ahead and start with putting our function in y1, which is what we would normally do anyway. So let's just do the x squared one, because we've done that one a bunch of times. Let's just do something we're familiar with. And then instead of, I don't know if you remember when we did our derivatives, we would go to math, and then we'd do n deriv, right? Well, just go one more down. FNINT, that's the function's integral. Okay, so we're going to do an integral, and the format is essentially the same. We're going to do y1, comma x, comma lower limit, comma upper limit, and this will actually integrate for us, 41 2/3. We can do it on the graph. If we've got, let's change our window a little bit. Let's go 0 to 5, and our min will go 0 to, well, we know it goes to 25. Let me fix my resolution. So there's my x squared from 0 to 5. Okay, this is what we spent so much time on last week. If I go to calculate, we've done dy dx before, but look right below it. And again, I know some of you found this already when you were tempted by the dark side, but for those of you that haven't had a chance to look, take a look now. Let's go here. There's our integral of f of x dx. I can literally just type in my lower limit, 0, type in my upper limit, 5, and watch. It will accumulate all that area for us, and we'll get our 41 2/3 just like before. Now, I'm using the TI-83 Plus. Some of you I know have some fancier versions. Well, good for you. You're just going to have to change your notation like we did for the derivative. You might literally, I think if I remember right, some of them actually look like this on your screen. Like when you hit enter, it'll show up on your screen that way, and you have to plug in the values where they go. So you just have to watch out for that. But those are your two ways to do it. Let's exit out of this for a second, and let's graph, what was it, 3x squared minus 2. Right? I'll do a standard window. I think I went from what? Negative 1. What did I do? Negative 1 to 4 of 3x squared minus 2. Negative 1 to 4. So let me change my window. Negative 1 to 4. And And I don't think I had to go down that far. Let's graph that. Okay. Now this one's kind of interesting because you've got, you've got some area below the curve as well, right? If you look over here, you've got a little area above the curve, right at -1, and you've got some area below the curve here, and then some area above the curve here. Okay? So this process will sort of find that net value for you. When it's above the curve, the area is considered positive. When it's below the curve, the area, the sign of the area is negative. Again, it's not negative area, it's just subtracting that area from the total. Okay, so your integral will be whatever that net value is. It could be a negative value. It's not saying you have negative area, it's just saying you have more area below the curve than you do above. In this case, though, I think we ended up with a positive answer anyway, but let's see what happens. Okay, let's go ahead and calculate our integral. And our lower limit was -1, and our upper limit was 4. And see what it does. Okay, and I think we had 55, right? So actually, I should have gone a little higher so you could see that better. Let me change my window here. What did I do? I went to 4, so that's going to put us at, 12, 1648, I don't know, 46, so let's go 50. Yeah, something like that, right? Let's calculate that again, just so it looks a little better. Integral from -1 to 4. Accumulate, accumulate, accumulate. There's the tiniest little bit above the curve here. You can't see it because I changed my window. But then I have all this area below. Of course, it got covered by the answer. There it is. All the area below is right here. That's considered a negative value. But look at all this above. So our answer being positive 55 kind of makes sense. Again, we can do it out here. I'm going to cheat. I'm going to do second enter. Oop, let me scroll up a little bit here. Second enter is like a copy, your entry. So it recopies my entry. See that? And it's in my y1. It's already there. The only thing I got to do is go back and change my limits. -1 to 4. And of course, it'll do the same thing here. I kind of like the visual. Kind of neat to see it. But either way, you'll still be able to get the value, whichever way you want to do it. This is a great way to do your second part of the fundamental theorem whenever you need actual values. It's not going to help too much with the first part outside of simply understanding that the derivative is the derivative of your integral is your integrand. You could always graph that and see that they match up. Okay? Hopefully this helps with the homework. If you have any specific questions on any of the problems from the homework, please let me know. And I think you guys will be in pretty good shape. Okay? Thank you very much. I will talk to you later. Bye.